All right, so here we go with topic 314, polar function graphs. Note, polar function graphs, you're only going to see polar functions at all in the multiple choice part. You're not going to see them in the free response questions. They could be in the calculator or the no calculator, most likely in the no calculator. I think I've read that. All right, so remember, we're basically doing f of theta right here. F of theta is r. When you graph something in the polar coordinate system, remember you're doing r and then theta. So we kind of have to do it backwards. We got to plug in theta to find the r value. All right, so let's do that down here. So remember sine, that's going to mean I have y-axis, my old y-axis symmetry. This is not really the y-axis on a polar coordinate system, but we can think of it as that. So we're going to say y-axis in quotations and symmetry. All right, so basically plug in 0. Sine of 0 is 0. So I get 3 minus nothing, that's 3. Pi over 6. Sine of pi over 6 is 1/2. So 3 minus 3 times a half. So 3 minus 1.5 is 1.5. Pi over 4. Sine of pi over 4 is radical 2 over 2. So I get 3 minus 3 times radical 2 over 2. So that turns into 0.8787 or 0.88 if you round it off. All right, so this, as you can see, gets pretty tedious. So we'll graph these first three, then I'm going to show you the rest, and we're going to graph them here real quick. All right, so 3, 0. So I go out to 3. Whoops, 3 is here, and then nothing. 1.5 and pi over 6. So I go out to 1.5. Let's see, this is 1, so 1.5 about here, and then up to pi over 6. So right there. So remember, this is pi over 6, pi over 4, and pi over 3. All right, and last one we'll graph here. We got pi over 4 and 0.88. So 0.88 is maybe a little bit right there, and go up to pi over 4. So there. So what's going to happen here is just basically this graph is coming around, and it's going to go like that. All right, and if you graph the rest of these points, I'll show them to you in a second and show you how to get them easier. But remember, it's y-axis symmetry, so whatever happens on this side is going to happen on that side. So let me get 3 right here. So it basically does this, and it's going to be a limacon. So it's going to come down to 6 right here. So it kind of curls around, comes there, and goes over there, like a little heart-shaped almost. This is more flat than I drew it, but oh, whatever. Okay, so this is a cardioid. It's a type of limacon. Okay, all right, and so these points that you have right here, let me show you on your calculator an easier way to do it. Now to do these, you can do them in regular, like look, I can do like 3 minus 3 sine of pi over 6. Let me put in pi over 6. So you can do that. You get your answer, okay? But if you want to do it, you can put the equation in here. But if you want to put it in polar form like it is right here, like you could type in 3 minus 3 sine x. You could do that. And then you could go back and you could say alpha trace y1 of, let's do pi over 4. Oops, what did I do? All right, see, there's my answer right there. But if you really want to see what you need to see, you go to mode, you change their function to polar functions. You make sure that you are also in radians. And then when you press y equals, look how it has r equals. Then you put 3 minus 3 sine. And then look, this x is now going to be a theta. All right, there we go. So now when I go ahead and press graph, there's my picture. I think I will do zoom square is usually a good one. Okay, and then, so there's my picture. It's not really that great, but you can see some things on it. You might do zoom in, zoom to, so you can see a little bit. Anyway, okay, so from here, if you want to do like alpha trace, now your things are r's. So you can do r of, and then you can put in all these values, like let's do pi over 3. All right, so there it is, 0.44019, so 0.4, okay? So just real quick, like if you want to complete the table, you can like pause and copy this down. All right, but that's basically it. All those points that we graphed, they're all here, and you already know how to graph points. Okay. All right. So let's go ahead. We're going to go ahead and try and figure out which equation this is. So I definitely see that it has old y-axis symmetry. So we're going to basically know that this is a sine function. So it's not going to be cosine. And then I'm just going to do some test points. Like I'm going to see what's happening here. So let's try, like I notice like pi over 6 is 3. So let me try to put pi over 6 in here and see if that comes to that point. So 3 times pi over 6 makes pi over 2. So 3 sine pi over 2. And this one also, negative 3 sine. And this, if I put in pi over 6, it'll be pi over 2, right? So what I'm doing now is I'm putting in pi over 6, and I'm trying to see the r value, right? So this one, the sine of pi over 2 is 1. 3 times 1 is 3. The sine of pi over 2 is 1, and so this will be negative 3. So let's see which one works. So 3 and pi over 6, that checks out right there. But negative 3 and pi over 6, that is not right. So it is letter A. Okay, and you know, if one of them doesn't seem to work for you, then you can do another test point if you need to. All right, so down here I have, again, old y-axis symmetry, so a sine function, so not these. All right, so let's do another test point. So a good test point here, let's try this 3 pi over 2. And it's nice and perfect. 3 pi over 2 is going to stay 3 pi over 2. So the sine of 3 pi over 2, so I am trying to plug in 3 pi over 2. The sine of 3 pi over 2 is negative 1. So 2 plus 4 times negative 1 will be 2 minus 4, so negative 2. And then here again, 3 pi over 2. Sine of 3 pi over 2 is negative 1, so it'll be 2 plus 4, that'll be 6. All right, so let's check it out. So 6 and 3 pi over 2, that's it right there. Because if I go to negative 2 and 3 pi over 2, oh, that puts me all the way up here. So that's not good. Okay, there you go. All right, over here. So from here on out, this just gets pretty annoying, but I'll try to do my best here. Okay. So this graph right here. So this graph, this is part of that graph. So a portion of this graph is here. All right. And so basically, if I wanted the whole graph, I would go from 0 to 2 pi. So let's try and put some points on here. I need theta, and then I'm getting my f of theta. Okay. So I'm going to put 0 on there. I'm going to put 2 pi at the bottom. So that would be like the whole picture. So they're asking me this part of the graph. So basically like these 2 points, when it goes in this loop, I don't know if it goes from here or it goes from there, but creating this loop, I want to know like where to start and stop to create this loop. So I'm going to use all these things that they gave me to try. So 0 I got. So pi over 2, yep, that's my next smallest one. So pi over 2. Pi, yep, pi, and I got 2 pi. I'll leave some space because I might need to do some in between. So if I do 0, sine of 0 is 0, so I'm going to get 0. Pi over 2, sine of pi over 2 is 1, so I'm going to get negative 3. Pi, sine of pi is 0, so I'm going to get 0. And 2 pi, same thing, 0. Okay, so they're telling me, let's see, I'm not sure about this yet, pi to 2 pi. So from pi to 2 pi, that's a pretty big gap, and the answers are both 0. So like, actually, I know that to be wrong. So if you start at pi, you're starting at 0, and then 2 pi is also 0. So those are the same 2 points. Like I can't, you're not gonna, I need to be down here at some place, all right? So they're basically asking me, this has to start and stop at these places or start here and stop there. Okay, so that's not it. So 0 and pi. So again, 0 and pi, that seems like a dud for the same reason. All right, so these are better, all right, because we've got some zeros here. So let's try pi over 2. So pi over 2, so negative 3 and pi over 2. So negative 3 and pi over 2. There I am. And then pi is 0. So there I stop. I feel like that's going to be it. So it starts me here and then it takes me around to there. Versus this one. 0 is 0. And then pi over 2 is negative 3. So that takes me to there. All right, so let's figure out something in between. So let me do something in between here that I know. So something between 0 and pi over 2 that I know the easy answer to for sine is pi over 6. All right, so the sine of pi over 6 is 1/2. Half of negative 3 is negative 1.5. So let's see if that little section, let's see if that's a point on this picture. So negative 1.5, negative 1.5, and pi over 6. Nope, that is not right. The stuff in between there is not creating this picture. Right, so it has to be letter B. Because if you try something in between here that you know, like for instance 5 pi over 6. 5 pi over 6, the sine is 1/2. Half of negative 3 is negative 1.5. So look, negative 1.5, 5 pi over 6, there it is. All right, down here, our second annoying problem. All right, here we go. So same idea. And we're just going to kind of treat it the same way. We got our thetas, and we have our f of theta. So I want to figure out which little section of the graph is created by which of these intervals right here. So let's do 0. I see on here pi over 6, pi over 3, pi over 2. Pi over 6, pi over 3, pi over 2. And then I got pi and 3 pi over 2. So pi and 3 pi over 2. So I'm just trying to do all these things so I can see like where they start and stop. All right, so 0. Cosine of 0 is 1. So I get 3 times 1. Pi over 6. Oh, but 3 times pi over 6. Well, 3 times pi over 6 is pi over 2. And cosine of pi over 2 is 0. 3 times 0. All right, pi over 3. 3 times pi over 3 is pi. Cosine of pi is negative 1. Negative 1 times 3 is negative 3. Pi over 2. 3 times pi over 2 is 3 pi over 2. Cosine down here is 0, so 0. All right, pi. Cosine at 3 pi. Well, 3 pi would be around and over here. That's cosine is negative 1. So negative 1 times 3 is negative 3. And 3 pi over 2. So 3 pi over 2 times 3 would be 9 pi over 2. All right, so 9 pi over 2's, that's 9 90 degrees. So 1, 2, 3, 4. It takes 4 to get around. So 4, 8. The ninth one would be here. Cosine there at 90 degrees is 0. So 0 times 3 is 0. All right, so let's check it out. Pi and 3 pi over 2. So if you're at pi, you're at negative 3 and pi. So negative 3 and pi is right there. And 3 pi over 2 is 0. So that could be it. Okay, so let's leave that one for a minute. All right, 0 and pi over 2. So if you're at 0, you're at 3. So 3, 0, yep, that could be it. But pi over 2 is 0. All right, well, that's not really helping me that much. All right, let's see, 0 and pi over 3. So here is my 0 spot. Pi over 3 is negative 3 pi over 3. That's wrong. All right. And 0 and pi over 6. So 0 and pi over 6. Okay, so, all right. So now we have a problem. Let's see. Let me look at these again. So pi and 3 pi over 2. So if you put in pi, you get negative 3. So negative 3 goes around to pi. Okay. And then 3 pi over 2 is 0. Okay. Let me just check again. So I need to check, let's check something in between there. All right. So in between pi and 3 pi over 2, something that I know the cosine of. All right. So let's put in something like pi and 3 pi over 2. Let's put in like, how about let's put in something with a 3 on the bottom, like 4 pi over 3. if I put a 4 pi over 3 here, which is in between these numbers, 3 times 4 pi over 3 is just 4 pi. So the cosine of 4 pi, is just like 2 pi, so it's 1, and 1 times 3 is 3. All right, so let's check. So, I forgot what I was doing, this one. All right, so negative 3 in pi goes to 3 and 4 pi over 3. That point is not on that section, so that's not good. Okay, this guy. So something between 0 and pi over 2. So 0 and pi over 2. So basically, anything between 0 and pi over 2, I have to hit all these points. So look, 3, 0, no. 0 and pi over 6, like it's not happening here. Because look how negative 3, this point would have to be in this region right here, because pi over 3 is before pi over 2. So pi over 3 is producing a negative 3. So negative 3, pi over 3, I don't want anything to do with that. That's not in this section. All right, it's letter D. All right, last one. All right, so this problem. So we have the full graph up here, none of this little pieces anymore. But what's happened, they're saying that there's 4 points on here, A, B, C, D. The domain of the function is restricted to between pi over 3 and 2 pi over 3. So let's just see what's happening there. So pi over 3 and 2 pi over 3. What's going on? What does that give me? All right, so put pi over 3 in here. 3 times pi over 3 is pi. Cosine of pi is negative 1. Negative 1 times 3 is negative 3. 2 pi over 3. That'll be turning it into 2 pi, because 3 times 2 pi over 3 is 2 pi. So cosine of 2 pi is 1. And 1 times 3 is 3. Okay, so basically they're telling me that the beginning of the section is here and the end is there, because they're starting and stopping me there. All right, so negative 3 and pi over 3. So negative 3 and pi over 3 is this one. And they're ending me at 2 pi over 3 and 3. So 3 and 2 pi over 3. So ending me at A. Okay, so they've told me that, hey, one of these pieces is the portion of the graph in quadrant 3 from C to D. So basically, if you're asking me to go from here to here and you're going through D, so you're going from C to D, and then you're going from D to A, because remember, this was point C and this was point A, and you're telling me that you're already going to go from C to D. Well, I have to finish and go to A. So it's basically coming around here and going like that. Okay, so D to A it is. All right, so just plugging in test points. All right, I'll see you in class. Bye-bye.